Today we're going to cover 4J, which is on linear modeling. So the linear objective is we're going to studying how we can model linear relationships in a graph. And the success criteria is I can model linear relationships. Pause the video here if you wish to copy down the learning objective and success criteria. These are the key ideas of 4J. We're going to apply our understanding of linear graphs in this exercise. And here are the steps how to do linear modeling. The first step is you're going to try to find the rule linking your two variables. So remember your variables are your two polynomials. Normally we have x and y. This time you'll probably be using other polynomials. You're going to then sketch the graph using what we've studied so far in chapter 4. And then you can then use the graph or the rule to solve the problems that are given. I'll give you time to copy this down by pausing the video. So let's have one example. We'll have April and she gets paid $20 plus $10 per hour. And the first question that we're going to do is write a rule for how much she gets paid using P dollars after working T hours. So the P is dependent on T because how much she gets paid depends on how many hours she works. We know that she gets paid $10 times how many hours she's worked plus the initial $20. So the rule here is P equals 10 times T plus 20. 10T, 10 times the number of hours she works, as it's $10 per hour, and plus 20 because she gets paid $20 initially. That's question 1. Let's have another question. It's going to ask us to sketch the graph of P versus T using 0, T8. It's just saying number of hours is between 0 and 8, so it's greater or so T is greater or equal to 0 and T is less than or equal to 8. What we need to do first, we're going to use our endpoints with T equals to 0 and T equals to 8. So it will start at T equals to 0 and T equals to 8. What we're going to do is plot these into our given equation. We're going to find the first starting point, which is when T equals to 0. If T equals to 0, that's P equals 20. It's also your y-intercept. And let's find another one. When T equals to 8, P equals to 100 because 10 times 8 gives you 80. 80 plus 20 gives you 100. That's where the 100 comes from. Can't see. We're going to use these two values to get out endpoints. Just have to get out of presentation mode for a while. There we go. So what I'm going to do, I'm going to sketch out my axis. I'm going to use P for my vertical axis and T for my horizontal. So this is how many hours we work, and this is how much she will get paid. Alright, here's T equals to 8, and I'm going to sketch out my vertical axis. When T equals to 0, it's P equals to 20. When T equals to 8, P equals to 100, and I'm just going to draw a straight line connecting these two points, and that's my graph. Moving on to another question, question 3. How much would she receive if she works for 4 hours? What we're just going to do, we're going to use the formula that we found in question 1. We're just going to sub in 4 hours, so that means T equals to 4. Plug it into your formula, P equals 10 times 4 plus 20. So P equals to 40, 10 times 4 is 40 plus 20, and then P equals to 60. So she gets paid $60 after working for 4 hours. Question 4. If April gets paid $50, how many hours did she work? Let's just say P equals 10t plus 20. That's the formula that we found. What we're going to do, we're going to just substitute in P equals to $50. So P equals to 50. 50 equals 10t plus 20. And we're trying to find out how many hours she worked. So we're trying to find t. I'm going to subtract 20 from both sides. So I get 10t by itself. So 30 equals 10t. Then I want to get t by itself because t is being multiplied by 10. Opposite of timesing by 10 is dividing by 10. That should be dividing by 10. I made it tougher. So it's actually dividing by 10. And I get t equals 3. So she worked for only 3 hours. This is what the questions you have to do. There we go. Good luck.